Hi all, Mr. Yeager for physical science, basically finishing up the force unit. Basically we've already finished up Newton's laws and what is force. This little section here, pretty quick, is we're going to look at what are different types of forces. We'll look a little bit at how objects move in a circle, and then how do we measure force if we had to do an experiment. Okay, so for this class, we don't really look at that many forces involved. We mainly use weight or gravity. Again, the official way would say weight. Gravity is more the acceleration. But weight is obviously the force due to gravity. And we can calculate it by doing m times g, mass times gravity, mass times 10 meters per second squared. All right. Now, weight does depend on the mass as seen here. It does also depend on the distance between those two objects. Okay. But we don't really look at that too much. That would be more of the fact that, like, if you do get farther and farther apart, you feel less gravity between those two. Again, weight is the force between two masses. Trying to spell. Okay. So if the masses are larger, there'll be more weight or gravity between them, gravitational force. If they're closer, there's more weight or gravitational force between them. Okay. So, like, for instance, the sun would have a lot of force with Mercury, with it being so close, versus with Neptune. Even though Neptune's a lot larger, with Neptune being so far away, the sun doesn't have as much gravitational force with Neptune. Okay. Some other forces we'll run into. We already said friction. It always opposes motion. And then the last one we also talked about already a little bit, air resistance. Okay, that will oppose the motion through air. Okay, but the one that we usually actually make you calculate quite a bit is weight. So weight equals m times g. M times g. All right. So with weight, it equals mass times gravity. It's a force measured in newtons. It's what you feel when you fall. Okay, gravity is what you feel when you fall. Again, gravity accelerates you 10 meters per second squared. So your weight is this combination of how large you are, your mass times gravity. We do abbreviate gravity in formulas simply as g. So g equals 10 meters per second squared. So if I had a problem, I said, what's your weight? If you weigh 70 kilograms, which is about 145 pounds or so. All right. Your weight would be mass times gravity. So 70 times 10. So your weight is 700 newtons. Now that seems like a lot, but it turns out a newton's a very small unit. So, I mean, I know we wouldn't want to step on a scale and see us read 700, but 700 newtons is about 150, basically 145 pounds. Okay. We just mention it because they would give you this if you need it. This is, I'm really only looking at the last column here. This is telling you the gravity of different planets. So you can see Earth right here, 9.81, basically 10. All right? And it's all depending on the size of the planet itself. You can see Jupiter, the largest planet in our solar system, has a gravity of almost 26. Okay? Mercury, well, yeah, if we don't include Pluto, Mercury, the smallest planet in our solar system, has a gravity of 3.6. Moon, our moon has a gravity of 1.62. Jupiter, you can see, only 0.42. So again, this is why you might feel lighter on other planets or heavier on other planets depending on the strength of their gravity. You can see the sun, if you didn't burn up, you'd be weighing a lot. You'd be multiplying your mass by 274 meters per second squared. And again, that's just because the sun is so massive that it creates a much larger gravity. So this is where we basically have our different gravities of planets. If you ever needed to use one, they would give it to you. Air resistance, again, that's the force of the air pushing back on it. We talked about this a little bit back in Unit 2 with introducing gravity and acceleration, which will fall faster through the air. If there was air, the bowling ball is going to fall faster because the feather is obviously going to be affected by air more. Okay, so it won't be falling as fast. If there was no air, as we already talked about, both of these things should fall the same speed. Okay? They'll have the same acceleration and speed all the way down. This actually comes from a video. If you look online, just say bowling ball feather video. It's a pretty neat YouTube video where basically they drop these things in a giant vacuum chamber and both of them fall down at the same speed. But if there's air resistance, it goes a lot slower. And I think they actually show both. We already mentioned free fall. This is when something's falling through the air. It's acted on only by gravity. Okay? So again, gravity, it would increase that velocity and make it speed up as it goes down. All objects fall at 10 meters per second squared. That's the acceleration. Again, what does that mean? Every single second, you're getting 10 meters per second faster. This leads to a specific type of situation called terminal velocity. Okay? And it's basically saying, do you keep on getting faster and faster when you skydive? If you skydive, which obviously means you're falling for a long period of time, do you just endlessly keep on getting faster? The answer is no. You don't keep on just getting faster and faster and faster. Why is that? The reason is your weight is pulling you down, but air resistance is pushing back up. If those two forces become equal, gravity and air resistance, if these two become equal, when equal, that means now we have what? Balanced forces. And what happens when you have balanced forces? There's zero acceleration. Now that doesn't mean you stop. It just means you'll keep falling at a constant speed. And we call that, when you reach it, terminal velocity. You're still going to fall down to the earth. You're going to reach the ground eventually. All right? It's just you're not going to get any faster. Now that does depend on your shape. Obviously, if a skydiver wants to go real fast, they pencil. Okay, they get very tight together. If they want to not fall as quickly, they spread out like in this picture. They kind of get that like more starfish type shape. Okay? So that's what we're looking at there. So terminal velocity occurs when both of these things are equal. Here we go. When the force of gravity equals the force of air resistance, you reach terminal velocity. This is the maximum velocity maximum speed you reach while falling. Okay? You fall at a constant speed. That's the big thing. So this is kind of a goofy one. I usually have physics students that struggle with this a little bit, where this is a constant this is a balanced force situation. So you're moving at a constant speed now, a very high constant speed. What if you're moving in a circle? I know we're kind of jumping from one thing to the next, but I mean, that's where we get at the end. We're just going through different types of situations. What if we're going in a circle? What causes you to move in a circular path? We call that a centripetal force. And a centripetal force is the net force that's pointing towards the center of the circle. It always points towards the center of the circle. This is a good example where you might be going one speed around the circle, but you're constantly changing direction. So yes, there is a force acting on you, and you are accelerating towards the center. Doesn't mean you're going towards the center. It means you're changing direction towards the center at all times. So a centripetal force is what causes circular motion. And that's really all that we do with circular motion. A centripetal force causes circular motion. Okay? And then I think on our last slide, how do we actually measure force? So first off, let's talk about this. How do we measure mass? We measure mass with a triple beam balance. We talked about that before back in our equipment video, in kind of our unit 0, whatever you want to call it. And again, a balance measures mass. It tells you how much is there. But I want to know the force of it. How do I measure force or weight? I use something called a spring balance. Sorry, all these things. A spring balance. So this is something they actually hang on hang the object on the little hook, hold it up in the air, and it'll tell you the newtons that the object is while it is in the air. Okay, it'll give you the force because at that time it's mass times gravity. It'll give you the force. Obviously, you could come back here and say, I found the mass. What do you then multiply that by? G, and you can find the weight. But we say the triple beam balance measures mass. A spring balance will measure force. And that's basically it. So very quickly reviewing, what are the types of forces we primarily run into are weight, friction, and air resistance. Weight is mass times gravity, the force between two masses. We looked at terminal velocity when the force of gravity will equal the air resistance against it, and you'll go a constant speed. Circular motion is caused by centripetal force, and then we measure mass with a balance and force with a spring balance. And that's it. That's the end of our unit on force. Thanks.